Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to important parameters associated with the movement of satellite around Earth. Previously we discussed the various parameters such as escape velocity, orbital velocity, time period of a satellite, the height and angular momentum of a satellite. We covered all those things. So in this video we are going to discuss another important parameter, which is the total energy associated with a satellite. So here again we have to go back to some of the earlier concepts which we have discussed, which we have covered. So we have to go back to gravitational potential energy. So if you remember, I have made a video on it. You can watch that video, and if you have not watched it, I request you to please watch serially all the videos one by one and then proceed in a systematic manner. Okay, so gravitational potential energy is the capacity of gravitational force to do work. So basically it is the work done in bringing an object of a certain mass, in this case small m, from a faraway distance, in this case from infinite separation distance, to a certain position in the gravitational field of this source mass, of mass capital M. So here capital M is the source mass and this is the test mass. The test mass is brought from a faraway distance, basically infinity, to a certain position in the gravitational field of the source mass. So let's say the test mass is brought from infinity to point P, which is at a separation distance of small r from the source mass capital M. So in this case, the gravitational potential energy of the test mass, it will be equal to, of the system, the two mass system, it will be equal to minus g capital M small m by small r. So here capital G is the universal gravitational constant, capital M is the mass, the source mass, small m is the test mass, and small r is the separation distance. So if we apply the same concept to Earth and satellite system, so in this case Earth becomes the source mass, which is the source of gravitational field. The satellite is within the gravitational field of Earth. So here the mass of the satellite is small m, mass of Earth is capital M. The total separation distance, as all distances are measured from the center, it is capital R plus small h, where capital R is the radius of the Earth and small h is the height of the satellite above the surface of the Earth. So a total separation distance of R plus h. So in this case, the gravitational potential energy of a satellite within Earth's gravitational field will be equal to U minus, which is equal to minus capital G capital M small m by small r, where small r is equal to capital R plus small h, the total separation distance between Earth's center and the satellite. So this is the gravitational potential energy, or simply the potential energy of a satellite. Now here if you see, it is negative. The negative sign it indicates, as I have already told you in that case also in the gravitational potential energy discussion, the negative sign indicates that the satellite is under the influence of the gravitational pull of the Earth, the gravitational force of the Earth. Work is done by the Earth to keep the satellite in its orbit, to move around Earth in a certain fixed orbit. So it is the gravitational pull or the gravitational force at work here. Work is done by the gravitational force. So that's why it is negative sign. So this is the potential energy of a satellite. Now we know the satellite, it moves around the Earth with a certain orbital velocity which is tangential to the orbital path. Okay, so because of the orbital velocity, the satellite will have a certain kinetic energy because of the orbital motion, the orbital velocity. So The orbital velocity, we have derived the expression of orbital velocity in the orbital velocity video. So the orbital velocity is equal to root over of capital G capital M by capital R plus small h, where capital G is the universal gravitational constant, capital M is the mass of Earth, capital R is the radius of the Earth, and small h is the height of the satellite above the surface of the Earth. So here we can write it as this in terms of small r. In terms of small r, where small r is equal to r plus h, we can write it as this. V0 is equal to root over of gm by r. Now we know kinetic energy is equal to 1/2 mv square, the velocity. So here the orbital velocity is there, so it will be equal to 1/2 mv0 square. So where small m is the mass of this satellite and v0 is its orbital velocity. So v0 is equal to root over of gm by small r. So v0 square will be equal to simply gm by r. So it will be equal to 1 by 2 capital G capital M small m by small r. So potential energy is minus gmm by r and kinetic energy is equal to 1/2 gmm by r. Now the total energy of a satellite is the sum of its potential and kinetic energy. Okay, it is the sum of the potential energy or the gravitational potential energy, which is because of the position of the satellite within Earth's gravitational field, and the kinetic energy of the satellite, which is because of its orbital velocity, the orbital motion. So if we add them together, the kinetic energy and the potential energy, we will have the total energy, which is U plus K, potential energy plus kinetic energy. So it is minus gmm by r plus 1 by 2 gmm by r. So it will be equal to minus 1 by 2 gmm by r. Okay, where capital G is the gravitational constant, m is the mass of Earth, small m is the mass of satellite, and r is the separation distance. Always remember, r is equal to capital R plus small h. In this discussion, small r is equal to capital R plus small h. R is the radius of Earth and h is the height of the satellite above the surface of the Earth, the total separation distance between Earth's center and the satellite. Okay, so the total energy of a satellite is given as this, minus gmm by 2r. Now here there are some interesting things. Again, the total energy of the satellite is negative, okay, the negative sign. So again here the negative sign, it indicates that the satellite is bound to Earth, it is bonded to Earth, and it moves around the Earth in a fixed circular orbit. It is because of the gravitational pull. Work is done by the gravitational force, That's why the satellite, it remains in a fixed circular orbit and it is bound to Earth. It moves around the Earth in a fixed path. Now, suppose we take a faraway distance. Let's say r is equal to infinity. A very far away distance, r is equal to infinity. In that case, the potential energy of the satellite, it will be equal to how much? U at infinity, it will be equal to minus g m m by infinity. It will be equal to 0 because r is equal to infinity, separation distance is infinity. So potential energy at infinity is 0. Then the kinetic energy. Kinetic energy is 1/2 gmm by r. So here also the kinetic energy at infinity, that is r is equal to infinity, it will be equal to 1/2 g capital M small m by infinity, which is equal to 0. So potential energy at infinity is also 0 and the kinetic energy at infinity is also equal to 0. So the total energy, okay, the total energy at faraway distance, it will also be equal to 0. The sum of kinetic and potential energy, both of them are 0. So the total energy is also 0 at faraway distance at infinity. When the satellite or any object, it is at a faraway distance away from the surface of the Earth, where the height is much greater than the radius of the earth in that case. Okay, so here we have derived the mathematical expressions for the potential energy of a satellite and the kinetic energy of the satellite. So for potential energy, we again use some of the concepts related to gravitational potential energy. Okay, the work done in bringing a body from a far away distance from infinity to a certain point in the gravitational field. So the source mass test mass concept, and we also use the concept of orbital velocity to determine the kinetic energy. Okay, so potential energy, kinetic energy, and the sum of both of them, that gives us the total energy. Okay, so the total energy is this. So this is the total energy of a satellite. Okay.